Good morning, friends. So today I'm continuing vector. This is lecture number 2. जब हम नए क्लास में जाते हैं और पहला लेक्चर रहता है एंड वी मीट अ न्यू फ्रेंड, हम कैसे स्टार्ट करते हैं उसके साथ, फ्रेंडशिप की शुरुआत कैसे करते हैं। सबसे पहले हम पूछते हैं नाम, व्हाट इज योर गुड नेम। तो यहां पे टॉपिक में वो क्या होता है, व्हाट इज दैट पर्टिकुलर टॉपिक मीन्स व्हाट इज डेफिनेशन ऑफ दैट पर्टिकुलर थिंग। फिर हम चलते हैं धीरे धीरे जानने की कोशिश करते हैं कि उसके फादर क्या करते हैं, उसके कितने भाई बहन हैं। तो वैसे ही यहाँ पे भी किसी भी टॉपिक को सीखते समय हम डेफिनेशन के बाद फिर देखते हैं व्हाट आर वेरियस टाइप्स ऑफ दैट, ठीक है। और बाद में चलते हैं एक बहुत ही इंपॉर्टेंट हेडिंग की तरफ, अलजेब्रा ऑफ दैट पर्टिकुलर टॉपिक। अलजेब्रा का मतलब होता है एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन एंड डिवीजन। तो यहां पे हमने व्हाट इज वेक्टर दैट वी हैव लर्न, देन वी हैव लर्न वेरियस टाइप्स ऑफ वेक्टर, देन अदर बेसिक डेफिनेशंस, एंड नाउ we'll go to what algebra of vectors. This algebra of vector consists of addition, subtraction, multiplication, division is not possible. और साइमल्टेनियसली ये सीखते सीखते why we have studied vector or any particular topic, its application, its use, that is the last part of the topic. तो वेक्टर हम लोग कैसे कंटिन्यू करेंगे। अभी हमने वेक्टर्स कर लिया, व्हाट आर वेरियस टाइप्स ऑफ वेक्टर्स, ये सब देखा, बेसिक डेफिनेशन देखा। नाउ विल गो टू व्हाट अलजेब्रा ऑफ वेक्टर्स। अलजेब्रा में पहली हेडिंग है लॉज ऑफ वेक्टर एडिशन। तो फर्स्ट हेडिंग इज व्हाट लॉज ऑफ वेक्टर एडिशन। व्हाई लॉज, व्हाई नॉट लॉ, बिकॉज मेनी आर देयर। व्हाई मेनी लॉज आर देयर, तो answer is what? Direction, because vector has got direction. How direction plays important role in various laws of vector addition, or in which case we will be applying triangle law of vector addition, in which case we'll apply polygon law of vector addition or parallelogram law of vector addition. तो सबसे पहले बेसिक बताता हूं, whenever this is one vector, this is terminal point of this vector is same as initial point of second vector. This is terminal point of first vector and this same point is what? Initial point of second vector. यानी एक का हेड दूसरे का टेल सेम हो तो देन वी कैन अप्लाई ट्रायंगल लॉ ऑफ वेक्टर एडिशन। और पैरेलल लॉ ऑफ वेक्टर एडिशन कहां लगता है? व्हेन इनिशियल पॉइंट ऑफ बोथ द वेक्टर्स आर सेम, दोनों वेक्टर का इनिशियल पॉइंट सेम है तो देन वी अप्लाई parallelogram law of vector addition. So let us start triangle law of vector addition. Sorry, this is not triangle. I want triangle. This is triangle ABC. This is vector A bar. This is vector B bar. We have been given only two vectors A bar and B bar जिनको ऐड करना है. We are adding them. So let A bar is equal to AB bar and B bar is equal to BC bar, the two vectors represented along two sides of triangle ABC. We are given only two vectors. We are representing them on two sides of triangle ABC. The resultant का मतलब होता है सम, that is A bar plus B bar is expressed along the third side of triangle ABC. Third side can be AC, it can be CA. The further part will be what? Third side of triangle ABC, such that initial point of resultant is the same as initial point of first vector, that is A bar, and initial point of A bar is what? A. Initial point of resultant is same as initial point of A bar and terminal point of resultant is same as terminal point of B bar. Therefore, A bar plus B bar is equal to AC bar. That is AB bar plus BC bar AC bar. This is known as triangle law of vector addition. Same way we remember PQ bar plus QR bar. PQQR gives what? PR. AC bar plus CD bar will give you AD bar. MN bar plus NP bar is equal to MP bar and so on. So this is called triangle law of vector addition. Now we'll go to what second law, that is parallelogram law of vector addition. In beginning, parallelogram is not given, only two vectors are given. We have to bring and represent on two sides of parallelogram in such a way so that their initial point remains same. Okay? So see the diagram of this. This is parallelogram ABCD. We need diagonal also. This is A bar. This is B bar. And this is the resultant. Let A bar is equal to AB bar and B bar is equal to AD bar. Be two vectors represented along two adjacent sides of parallelogram ABCD. Since length AB same AD same as length BC, since opposite sides of parallelogram are equal and parallel, length AD length BC and directions of AD bar and BC bar are same. Therefore, AD bar is equal to BC bar. So this implies BC bar is also A bar. Consider AB bar, that is A bar plus B bar, because we are adding the two vectors. So consider A bar plus B bar, because we are adding the two vectors. A bar is what? AB bar, and B bar is what? AD bar. AB bar plus AD bar is nothing but BC bar. It is AC bar by triangle law of vector addition. Therefore, A bar is AB bar plus AD bar is same as. So in this case, resultant of the two vectors is nothing but expressed along the diagonal of parallelogram. AC bar. This is known as parallelogram law of vector addition. The next is polygon law of vector addition. Polygon means what? A plane figure which is bounded by three or more than three sides. If it is bounded by three sides, its name is what? Triangle. Four sides quadrilateral, five sides pentagon, and so on. So how the law is applicable in case of triangle? So first let me give the law and then I will explain in triangle as well as quadrilateral. If number of vectors are taken along consecutive sides of a polygon, in continuous direction, there should be continuity in the direction. In continuous direction, then their resultant is null vector. For example, in triangle ABC. In triangle ABC. By triangle law, of vector addition, AB bar plus BC bar is what? AC bar. And AC bar is what? Minus CA bar. Bring minus CA bar on this side. Therefore, AB bar plus BC bar plus CA bar is what? Nothing left means zero vector is left. So if AB bar is taken as what? A bar, BC bar is taken as B bar, and CA is taken as C bar. So A bar plus B bar plus C bar is what? Null vector. So if number of vectors are taken along consecutive sides of a polygon in a continuous direction, there is continuity in the direction, then the resultant is null vector. See second example. Let us take any quadrilateral. ABCD, AB bar, BC bar, CD bar and DA bar. This is A bar, B bar, C bar, D bar. Since AB bar plus BC bar plus CD bar, if we add AB and BC, will get AC, AC, CD will give you what? AD. So the resultant is what? AD bar. And AD bar is what? Minus DA bar. Bring minus DA bar on this side. AB bar plus BC bar plus CD bar plus DA bar is what? Null vector. That is A bar plus B bar plus C bar plus D bar is what? Null vector. So this is polygon law of vector addition. Next one is prove that vector addition is commutative. For commutative property, we will take a parallelogram. A, B, C, D. This is A bar. This is B bar. Let A bar is equal to AB bar and B bar is equal to AD bar. B2 vectors represented along two adjacent sides of parallelogram ABCD. To prove that vector addition is commutative, that is to prove that A bar plus B bar is equal to B bar plus A bar. Now, length AB is equal to length DC. And directions of AB bar and DC bar are same. Therefore, by equality of two vectors, AB bar is equal to DC bar. So this implies DC bar is also A bar. Similarly, AD bar is same as BC bar. AD bar implies BC bar is also B bar. Consider A bar plus B bar. A bar is what? AB bar, and B bar is BC bar. AB plus BC will give you what? AC bar by triangle law of vector addition. Addition. So A bar plus B bar is equal to A bar plus B bar is equal to AC bar. Equation number 1. Consider B bar plus A bar. B bar is what? AD bar, and A bar is DC bar. AD bar plus DC bar is what? By triangle law of vector addition. So B bar plus A bar, AC bar, equation number 2. From 1 and 2 we get A bar plus B bar is equal to, implies vector addition is commutative. Commutative. Next is vector addition is associative. Uh, to prove that vector addition is associative, we will take any quadrilateral. A, B, C, D be any quadrilateral. We will take AB bar as what? A bar, BC bar as B bar, CD bar as what? C bar. Let A bar is equal to AB bar, B bar is equal to BC bar, and C bar is equal to CD bar. Be three vectors represented along three sides of quadrilateral ABCD. To prove that vector addition is associative, that is to prove that A bar plus B bar plus C bar is equal to A bar plus B bar plus C bar. Consider A bar plus B bar plus C bar. A bar is what? AB bar plus BC bar, and C bar is what? CD bar. AB plus BC is what? AC. Plus CD bar. By triangle law of vector addition. AC plus CD is what? AD bar. Again by triangle law of vector addition. So A bar plus B bar plus C bar is what? AD bar. Write this as equation number 1. Now we'll find out A bar plus B bar plus C bar. A bar is AB bar plus BC bar plus CD bar. Now BC plus CD will give you what? BD by triangle law. By triangle law. AB plus BD is what? AD by triangle law. So this time also we are getting A bar plus B bar plus C bar is what? AD bar. Equation number 2. From 1 and 2 we get A bar plus C bar is equal to A bar plus as required. Next very important thing is what? Position vector of a point with respect to a fixed point which is called origin. For this, let me draw the diagram. we take right hand system of vectors. In this case, this is taken as x-axis, this is your y-axis, and this is z-axis. The point where they are meeting, that is origin. Let P is any point in this coordinate system. Any point on x-axis is of the type x comma 0 comma 0. That is on x-axis y coordinate 0, z coordinate 0. On y-axis x coordinate 0 and z coordinate 0. So any point on y-axis is what? 0, y, 0. Any point on z-axis has x coordinate 0, y coordinate 0. So point on z-axis is what? 0, 0, z. If point lies in xy plane, then its xy plane, then its z coordinate is 0. So point on xy is what? X comma y comma 0. Point on yz plane has x coordinate 0. So 0, yz. Point on xz plane has y coordinate 0. So it is what? X, 0, z. If a point lies in space, then its all three coordinates will be non-zero. As in this case, you are observing P is what? A point in space. From point P, draw PM perpendicular on xy plane. So M has coordinate x, y, 0. From point M, draw MN and MT draw MN and MT. MT perpendiculars on x and y axis respectively. So length ON will be what? X, which is x coordinate of point. Length OT is what? Y. So if length OT is y, length NN will also be y, because opposite sides of rectangle. And length MP is what? Z. And if you draw perpendicular on z axis, this is also z. Let P corresponds to x, y, z, be any point in space. Draw PM perpendicular on x or y plane. Therefore, M corresponds to x, y, 0. Draw MN and MT perpendiculars on x and y axis respectively. Therefore, length ON is equal to x, and length OT is what? Y. Length OT is Y, so length NM is also Y. Therefore, length NM is also Y. And length MP is what? Z. Since I bar, J bar and K bar are unit vectors, since I bar, J bar and K bar are unit vectors, along x, y and z axis respectively. Therefore, ON bar is what? Is xi bar. NM bar is what? Yj bar. And MP bar is what? Zk bar. Position vector of point P position vector in short is written as what? PV. Just like physics potential difference PD, so same way here PV for position vector. Position vector of point P with respect to origin O is OP bar and is defined as OP bar is what? ON bar plus NM bar plus by polygon law of accretion. Therefore, OP bar is what? XI bar plus YJ bar plus ZK bar. Now we need to find out magnitude of OP bar. To find magnitude of OP bar, so see, we have to find out magnitude of OP bar. So this is right angle triangle. ONM. By Pythagoras theorem, OM is what? Hypotenuse, because it is opposite to 90 degree. OM square is what? OM square plus NM square. To find OP bar in right angle triangle ONM by Pythagoras theorem, OM square is what? ON square plus NN square. So OM square is what? X square plus Y square. In right angle triangle OMP by Pythagoras theorem, OP square is what? OM square plus MP square. OM square we got X square plus Y square, and MP is what? Z. So length OP is what? Root of that is length of OP is nothing but magnitude of OP bar. X square plus Y square plus Z square. Hence, if point P has coordinate x, y, z, then position vector of point P with respect to origin is what? OP bar. X coordinate will multiply with I bar plus Y coordinate with J bar plus Z coordinate with K bar. And magnitude of vector is nothing but root of I component square plus J component square plus K component square. This is magnitude of vector. Next theorem is what? If P has coordinate x1, y1, z1 and Q has coordinate x2, y2, z2, be two points in space, then prove that PQR is this. This is our coordinate system, x-axis, y-axis, z-axis. This is origin. This is point P. This is point Q. P has coordinate x1, y1. Q has coordinate this is OP bar, OQ bar, and we want PQ bar. Since P corresponds to x1, y1, z1 and Q corresponds to x2, y2, z2, be two points in space. Their position vectors with respect to origin O be given as OP bar is what? x1 I bar plus y1 j bar plus z1 k bar, and OQ bar is what? x2 I bar plus y2 j bar plus z2 k bar. Now in triangle OPQ, by triangle law of vector addition, OP bar plus PQ bar is OQ bar. So PQ bar is what? OQ bar minus OP bar. This is very important formula. Position vector position vector, sorry, PQ bar is what? Position vector of terminal point minus position vector of initial point. Therefore, PQ bar is what? OQ bar we have got x2i plus y2j minus x1i plus y1j plus z1k. And when you subtract, you'll get x2 minus x1 I bar plus y2 minus y1 j bar plus k bar. Thank you very much. Listening is the very good habit. हम किसी की बात कम सुनते हैं और फटाक से डिसीजन ले लेते हैं. तो सुनना, श्रवण करने की जो ताकत है वो सबसे बड़ी ताकत होती है. तो लिसन फर्स्ट एंड देन एक्ट. Thank you very much. Next lecture will continue further part of vectors.